Good afternoon, ladies and gentlemen. Welcome to TechEd webinar series, our interview to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insights of various domains. The topic of today's session is Cloud Computing Series Session 8, Service Delivery Model for Cloud Computing. Our guest speaker today is Mr. Vipin Sahane, head of Megaseas India Private Limited. Vipin Sahane is an aficionado and an avid learner which goes true to the spirit of IT. An alumnus of the Delhi College of Engineering and with 25 years of being into IT profession, he brings with him a wealth of experience and knowledge on the various facets of IT. He has completed his post-graduation in Technology Management from the Department of Management Studies at the IIT Delhi. Starting with CMC Limited as programming resource on COBOL, he quickly migrated to IT project management and was associated with the prestigious Impress project for the Indian Railways. He subsequently turned entrepreneur and has the distinction of successfully bringing a number of office automation software products to life. As an entrepreneur, he also set up a service organization with a pan-North India footprint. ERP implementation in various countries has given him insights into service delivery across various verticals and different cultures. He is currently heading Megaseas India Private Limited and aims to bring a plethora of services around cloud for national and international markets. Prior to joining Megaseas, he has been responsible for bringing to life another startup for cloud services. This was an infrastructure initiative that is actually delivering cloud computing for SME segment. Built on robust infrastructure, the cloud computing is delivering cost-effective yet scalable IT infrastructure to the SME segment for last 5 years. Over to you, Mr. Vipin.
Thank you, Shweta. Hello, everybody. I'm Vipin Sahani, and I'm currently heading, as introduced by Shweta, a company called Megaseas, where I'm planning to deliver a lot of cloud services to national and international markets. Today I'll be talking about the service delivery model for cloud computing. My presentation today would consist of why cloud. We are all familiar with the terms about IaaS, PaaS, and SaaS. What do these actually mean in terms of service deliverables? Hence, I will be talking about what are the constituents of a service delivery model in a cloud environment. We shall also have a look at what is happening behind the scenes. Who benefits and how? Now, in any service delivery model, we have to create a win-win situation where the customer benefits. And I should be able to do so, demonstrate the same to you through a small case study. We'll follow this up with a question and answer session. The basic issue of why the cloud starts with, let us understand what are the IT challenges that the environment or the industry or the enterprise is facing today. I started my career 25 years ago, and at that point of time one had to explain a floppy drive to a user. Today the environment is much different, and there is a complete dependence on IT. IT is life, as some of the people say. Although IT is life, but IT is hugely capital intensive. And in today's recessionary trends, capital expense is a strict no-no. Over last years that I have been working, CIOs or technology people or the sales people tend to make technological mistakes. For example, we could be buying a server today or a set of infrastructure which, due to certain technological environmental changes, becomes outdated before its estimated life. You could have bought a storage which is no longer being supported functionally by the manufacturer. So it's a technological mistake that you made. Or we may invest into a backup solution which actually is not the best, but when it came to evaluating one with the knowledge that you gain through experience, made a certain technological mistake. Now this is a mistake that in an purchased infrastructure you have to live with. Overall, IT budgets have been shrinking. 20 years ago, IT people were the blue-eyed boys in an organization. Not anymore. IT is also being seen as an expense head, and there is pressure on IT people to cut down on IT spending. All this is not such a welcome news for IT people. What has also happened is the penetration of internet, advent of mobile technology, advent of web technology. Business processes have changed altogether. We still remember the days when you had to go to the airline's office to buy an airline ticket. You would be welcomed by a saleswoman who would offer you a nice cup of coffee, and then you would get your ticket in a very fancy jacket, which the whole process was not only time consuming but was also expensive. Look at the way airline tickets are being issued today. It's a self-service model. You book online, you print your ticket online, you go to the counter and you show your ticket on the smartphone, and you have access to the airport. So the business process has been turned upside down. This is an IT challenge that the CEOs of today face every day. Not only this, the users have become much wiser, and they are looking at better service from the IT people. So IT department is no longer carrying a halo around it. People are looking at IT to deliver services that they expect IT to be delivering. This is not the end of the affair. Business content has been growing humongously. IT manpower, the lesser said about it, the better. We all face attrition challenges, and IT is among the highest attrition industries in our country today. While the industry may be going through recessionary trends, it is impossible to talk to an IT person and tell him there are not going to be any increments this year. Another challenge that IT manpower continuously poses is about the skill set. Now, with hugely evolving technologies, new skill sets are required. Old skill sets are no longer in fashion in quotes. The old skills may not be working or may not be workable. And there is a pressure on the manpower to continuously upgrade itself, and within the organization to upgrade to newer technologies is also there. IT infrastructure maintenance poses its own set of problems because of a unique problem to our nation, which is that we are a power-starved nation. We do not get enough electricity to be running our basic infrastructure services. So you have to rely on UPSs, you have to rely on gensets, which mean additional point of failure. Vendor management is a problem that everybody faces, whether be it IT or be it non-IT. However, business continuity is something that is new. While yesterday the businesses would shut down at 5 o'clock, IT businesses do not shut any time of the day. So IT is supposed to be up and running 24/7. I mean, if you want to go to Flipkart, you expect the site to be up 24/7. It is not that during working hours you will be shopping on any customer portal, but yes, in the middle of the night you could be shopping on a customer portal. Also, coming in our compliance regulations, we've all heard of SOX or Act, which necessitates that there be so many years of email data pertaining to financial transactions be kept alive. What does it mean? It means that the volume of data in your organization is set to increase terribly. And this is constantly pushing the boundaries of what IT can achieve. Storage cost is not going down, but yes, the amount of data that needs to be stored continues to go up. It is very difficult for any IT wala to junk data. Let us look at what is driving us towards the cloud. An organization is looking at cost savings or at least containment of its IT expenses. Like I just mentioned, IT manpower skill set is an area of concern. constant requirement of specialists. You need a backup specialist, you need a recovery specialist, you need a power specialist, you need a firewall specialist. But let us take the case of an organization which is manufacturing cups and saucers. Their prime job is to manufacture cups and saucers, not to look at the IT behind it. But yes, IT is life and they need to do so. So it is eating into the CEO's time, which is reducing his focus, and time to market is getting cut. IT today demands time from the top management of the organization. So it is impacting on the core competence of the organization. In the past, we have seen many organizations whose core competence was something else, but they did so well at IT that they spun off IT companies. But it obviously means that there is some time spent that has gone out. Another outsourcing need, or the need to go to the cloud, comes from the huge impact that business continuity demands. If we look at various components of security, management, insurance, business continuity, these are all parts of a jigsaw puzzle that the IT needs to assemble and present the right picture. This business continuity, it is not that you cannot achieve business continuity while you are having in-house. But as we progress through the presentation, we'll come to know that this can be frightfully expensive as you continue to do it in-house. We all run cars and we all run scooters and mopeds. To service them yourself is not an easy job. It is not the cheapest job either. Giving it to a roadside mechanic may be a better option. IT environment in most of the organizations has evolved. So from few desktops a decade ago to multitude of servers, to multitude of applications, to multitude of accessing devices, including mobile phones today, we have seen a server sprawl happen within a small enterprise also. So, and the application providers have added to this conundrum by demanding separate resources. And so what has happened is we have had multitudes of databases where the resource utilization may be low, but it has also led to isolation of application and data. So HR data is different and sales data is different. While sales performance of an individual should be a part of HR data, but somehow these two remain disconnected somewhere. Backup is another issue which is of utmost importance and utmost concern. I still remember my days when I used to conduct interviews for freshers, and one of my questions used to be, please write down a backup command and a restore command when you are restoring it to a different directory. And I promised that most of the students would fail here. The story has evolved, but it has not changed. The backup and restore continues to cause problems. And of course, without addressing the staffing issue, one cannot proceed on the primary outsourcing. So if we see a picture like the I see on my screen existing in an organization, it is cause for alarm and something needs to be done about it. So let us see how is cloud computing happening. So while if we were to look at the slide on the screen, how does the cloud come to happen? So at the first stage, there is consolidation that needs to be done. So this consolidation can be managed better or can be handled through virtualization. Virtualization would mean automation again and metering and chargeback. Metering and chargeback are new words that are appearing in the IT, where chargeback is something, we are all familiar with cashback, but chargeback is new to us. And as part of automated processes, metering and chargeback is going to make a strong entry into the IT infrastructure. And the day we can start self-provisioning of the cloud, we have a complete installation of cloud happening, be it inside the organization or be it outside the organization. And as we progress through the presentation, we will also see that what are the various models of the cloud. You know, today we are all believing that the cloud exists outside. You know, Amazon or Azure, they make us appear as if the cloud is outside. But the cloud can coexist outside, within the organization, and live happily together. That is what we are headed for. So if I were to look at this slide once again, the various stages of migration to the cloud of any organization, whether it is planned or whether it has happened, goes through a cycle of consolidation, followed by virtualization, then a section of automation comes in, and then provisioning of the cloud comes in. So it's a data center who's offering services on the cloud. He has to be on the right-hand side of the graph, offering self-provisioning, metering chargeback, mobility, and virtualization layers to the customer. So that is how the cloud will make its appearance felt to the various sections of the users. And that is the way we've seen it happen also. Today you can buy Amazon by the hour. So what are we doing? We are enabling self-provisioning, and we are allowing metering and chargeback so that when the server is being shut down, there is no billing that is happening. What is the cloud? The photograph that you see on the screen is of a very famous man. I'm sure all of you are aware of Jeff Bezos, who called cloud as a muck. It abstracts infrastructure complexities of server applications, data, and heterogeneous platforms. Famous words from a very famous man. However, they need to be simplified or be explainable to a technical audience. So it's a model for enabling on-demand network access. While I've been talking to a couple of experts, somebody has even mentioned, emergence of a stored network. We'll talk about it some other day. But yes, on-demand network access is the key. So when you are logging into Hotmail or your Google account, you are accessing somebody's network, which is available to you 24/7, which is ever expanding, which is very elastic in nature, which presumably never goes down. It is very rare that Hotmail or a Yahoo or a Google would throw back a message to you saying that the servers are down, please try it. It has happened, yes. But look at the percentage of these messages occurring. Your data not being retrievable. In fact, we are all fighting, that my data is being replicated at so many places. I don't know when I delete, does it actually get deleted from the rest of the world, or is it available everywhere? And rapid provisioning is another key that cloud computing demands. And what does it deliver? It delivers availability. It consists of 5 essential characteristics that I will be talking about. It consists of 3 service models and 4 deployment models. As we progress, I'll be sharing what these 5, 3, and 4 deployment models are. Most of us are familiar with these terms. I am making an attempt to make us more in-depth knowledge onto all of these. What are the 5 essential cloud characteristics? As we've already mentioned, on-demand and self-service. Availability, high availability, and being available to me when I need it. So whether it be the application, be the infrastructure, or be the platform, we are always worried about, on-demand is the term that is required. So as they say, the Gen Y today is impatient. On-demand is just an extension of that. Network devices the prices have gone down, internet has become a commodity. That is what all sales people keep telling me. Although it is still unaffordable, and some of the service providers have been raising prices also. But broad network access is the order of the day. Being connected is what is required. Today we have cell phones that are always online. Today we have laptops, of course. Today when you are attempting a survey and it says, are you on the net 8 hours, and if you say no, I think you are out of sync. However, the term resource pooling needs more explanation. which is a direct result of virtualization that has come of age, and it delivers resource pooling by terms of mixing of server CPUs, availability of greater RAM, sharing of resources, and thin provisioning of disk. So you could be looking at half a GB of space expandable to 500 GB of space on a single volume or multiple volumes within a data center. Of course, we have cases where your data could be spanned across continents. The word location independence has lost its meaning because the IP address is ubiquitous. So you are the number, the 12-digit number that each IP device gives makes us location independence. But yes, it's an essential characteristic of the cloud. I would be wrong if I say that scalability is not required on the cloud. Today, all applications that are being designed, all hardware that is being designed is for a load that is unknown. While you may be using your SAP implementation and you know what your load is, but at times even that infrastructure that you have becomes insufficient because of so many constraints that can happen. So everybody talks of rapid elasticity. Service has never been measurable. However, the cloud demands that the service be measured. That is where the concepts of metering, chargeback, SLAs have come into being. And they are here to stay. It is not that they will disappear tomorrow. So 5 essential cloud characteristics would be as detailed here. On-demand self-service, broad or close to unlimited network access, pooling of resources, coagulation of resources, having the ability to access more than what you have provisioned, or you feel that having access to more resources when required. Irrespective of your geographical location, you should be able to access. Of course, this is subject to the availability of network there. And whenever you are demanding more resources, it is not that you have to go with an application to the CIO that I need additional hard disk space. This should happen on the fly, and either you should be billed for it, or when you are not using the space that you are asking for, you should be given a charge back for this. Service measurability, of course, is important. So these are essentially the 5 very cloud characteristics that we expect from a cloud service provider or an in-house cloud. Having talked about these, what are the 3 cloud service models? These are very, very apparent and very, very simple terms today: SaaS, PaaS, IaaS. So going in the reverse order, infrastructure as a service is the first form of cloud computing that exists. They may or may not be on a virtualized platform. And as I go ahead, I will be talking about how can IaaS be without virtualization. We could have platform as a service, and we could also have software as a service. If I were to talk about a mail application, it is a simple case of software as a service. So you are being offered a service which you use, and today it is free, it may be payable tomorrow, and you get out, period. Cloud platform as a service. So if a cloud provider is offering you a complete development environment on a go-to basis, it could be platform as a service. And going to the next slide, I'll just explain to you what infrastructure as a service would mean. So if I were to look at the various service model architectures, they exist in this fashion, again going from bottom upwards. At the root lies infrastructure as a service. But when we talk about platform as a service, it cannot exist without infrastructure being available as a service. Similarly, if I were to talk about software as a service, it cannot exist without PaaS, and it cannot exist without IaaS. So at the top of the heap lies software as a service. which includes platform as a service, which includes infrastructure as a service. And as we discuss, we will be talking about what are the service models to support this architecture. So while infrastructure may require different level of service and service constituents, platform as a service may require different constituents. Similarly, software as a service may require different constituents. Although when I have drawn this architecture, I have drawn sharp bold lines between these three, but these lines actually are very blurred. These definitions exist so as to be able to convey to the user. However, at so many places you will find that these lines are often missing or blurred. What I mean to say is that infrastructure, platform and software as a service come so close to each other that at times it may become very difficult to say whether it is an IaaS, PaaS or SaaS. But yes, one needs to define terms because we engineers are known to have crisp definitions. However, in real life these lines may or may not exist in an implementation. If I would look at infrastructure as a service, it essentially means delivery of computer hardware as a service. So the hardware could include storage, it could include networking equipment, it could include physical space in a data center, it could include firewall, intrusion prevention devices, and detection devices. It could of course include servers. It could also have a layer of virtualization, which is actually a piece of software to manage these resources. But virtualization may or may not be the necessary part of it. So if you see the value visibility to the end user, if as an end user you are using Hotmail as your preferred email, you do not see what is the infrastructure behind it, what kind of storage you have, whether it is Hitachi or whether it is HP or whether it is Sun Storage. The Hotmail user is completely unaware of this. Today when you book your LPG refill on the net, you're not bothered about what is the hardware that Indian people are using. It is you're completely transparent to this. So the value visibility is actually in the reverse order. A software user does not see what is the layer of soft platform that is being there and what is the layer of infrastructure that is being there. It may be virtualized, it may not be virtualized. One of the simplest cases of an enterprise would be of infrastructure as a service would be that an enterprise moves all its existing hardware servers to a data center to take advantage of power, cooling and monitoring service. For example, if you have a small organization which is generating teacups and you have one server which is monitoring your production data, this server could get out of your office and go into a data center and be available to you at least on the power and cooling front 24/7. You could additionally have your infrastructure provider give a backup to this. So an enterprise could move to a data center by just asking for support on power and cooling. It could also extend monitoring. For example, you have an OS on the hardware that you move to the data center. This OS needs to be patched, its security checks need to be done, it needs to be restarted once in a while. All this could be outsourced to the data center. Alternately, you could be doing this remotely sitting in your office if you have IT infrastructure staff available to you. So infrastructure as a service will not exist in isolation, that it is just about power, cooling and monitoring services. It is about power, cooling, monitoring, support, OS support, DB level support, backup support. So there could be a lot of services that you could add with it, while having these in-house could have been slightly expensive. For example, if you were to take a backup of your existing data as a database, so you would probably need somebody who understood MS SQL database backing well. This gentleman would not be very good at managing your Ethernet cables. So you would end up having two resources. within the organization. One who is looking after the connectivity within the organization, and the second one who is looking at OS and who is looking at data backup. Now data backup is probably 1 hour job to be happening either every day or let's say once a week. So this gentleman who you have kept for backup and OS monitoring is not being productive all the time. If your network cabling and your physical infrastructure on the network is very stable and it has been done very well, then your network gentleman is also redundant, but not dispensable. So when you're talking about infrastructure as a service, you do tend to have manpower which may not be productive, but they need to be there. Good old electrician within a small organization did many other jobs. He would double up as a security guard, he would double up as a kitchen assistant, and he would also double up as an assistant delivery boy or a short distance courier, and be able to still retain his job as an electrician and perform the duty as well. But he was multitasking. He was multitasking on a low skill job. When you're talking of high skill jobs, multitasking becomes to a degree a motivational result. So that is what one faces when you're talking about infrastructure as a service. But when we talk about platform as a service, it includes more than just delivery of infrastructure. So let's say you have an environment where currently you are a development organization and you are doing your development on .NET. So you have a delivery server, you have a test server, you have a beta test server, and then you have a production server. Of course, you need another virtual safe server to be managing your code. So you have about 5 or 6 servers sitting within the organization who are actually helping the programmers do their development. Now these servers are available to your organization. You have bought their licenses and you continue to use them. Now if another organization wants to do all this, it has to have a same stack of servers. So another .NET developer will set up all these 5-6 servers within their office and replicate what has been done in another organization. However, if a data center provider gave this as a service, so it sets up a BSS, it sets up the Windows-based development server, it sets up another SQL server, it sets up another production server and a beta test server, and gives multiple users the option to use these services and also create a separate window for each one of them, what is known as multi-tenancy. Then the cost of developing software for all these organizations could probably come down, and they could do without investing in so much hardware. So this is when somebody would be making the licenses available, making the underlying hardware available, making the network switches and storage and internet available, and people just log in from their laptops, do their development and get out. So the entire stack of 5-6 servers that you need to maintain within your organization, just get out and you use them, and the cost of usage can go down. So this is a case where platform comes in as a service. If you take an example of, like I said, data center service provider builds the software development hierarchy to facilitate development for multiple clients, each having multiple developers. So in this case, the organization saves on the capex, it saves on maintaining these servers, and all it needs is a login account into these servers and their developer, and the confidence that the data that they are creating is safe, or a conviction on the robustness of a multi-tenant architecture. This is what is required. And if we were to look at software as a service, it is simply a business application designed for a specific purpose. Look at Salesforce.com. You know, their catchphrase is success, not software, although it is a software company. So it is a solution, it's a CRM solution that takes IT out of an application. So your user in a sales organization would be trained on how to log into a CRM, how to be able to use it, and how to be able to extract reports out of it, and how the management will use these reports to manage their sales force. Now, what has software as a service enabled? The software as a service Salesforce.com has enabled the users to not look at software as something weird, to not look at platform underneath it, and to be completely oblivious of the hardware behind it, to be completely oblivious about the database behind it, to be completely oblivious about how the backups are happening, to be completely oblivious that the server could be sitting in the US and somebody in Tumkur could be using it. So location independence comes in. If there are 500 Salesforce on the ground, they are all having access to it 24/7. They could use it at leisure, and the product is always available. So if one were to look at the 5 characteristics, an application like this meets all those requirements. So Salesforce is a software as a service, and it includes platform on which this product has been developed. It includes infrastructure that is required to run all these products. So this is what is happening when you talk about SaaS. SaaS would be typically of single tenancy, simple multi-tenancy, and fine-grained multi-tenancy. For example, if you are using MS Exchange, which your organization has hosted on the cloud, so you create your own infrastructure architecture on the cloud. By infrastructure architecture, I mean you have a mail server, you have a role-based server, you have an Active Directory, you implement it on the cloud. So some cloud provider gives you all these servers, you buy these licenses yourself, you deploy them, you manage them. So you have taken the hardware from the customer, have deployed your Exchange on it, and then you are running it. On the same set of physical machines, another set of customers doing the same things. So they are all running multiple instances of MS Exchange, MS SQL, and running their MS Exchange services. So the software of mail delivery is being run on the infrastructure, but in a simple multi-tenancy. However, fine-grained multi-tenancy is something that is desirable. For example, if we are all software developers and we use MS SQL as our underlying database, somebody creates a large instance of MS SQL Enterprise and gives us access to each of our slice. So using multi-tenancy to the full. So the license cost for MS SQL is 1, the users are many, and they all get security of being able to access SQL through their own set of passwords, or the confidence that the data is safe. So software as a service could be delivered in 2 models, simple multi-tenancy and fine-grained multi-tenancy, where all resources are shared, but customer data and access capabilities are segregated within the application. So the platform of MS SQL segregates all of these and gives one common face to the person who is using it. So if you are running an application that uses MS SQL, so there are 5 such applications for 5 such developers, while the underlying database is single. This is a classic instance of an infrastructure as a software as a service with fine-grained multi-tenancy. This is what Salesforce.com did, and this is how they've been able to bring down the cost of development and the cost of deployment low. What are the various deployment models of the cloud? We'll just take a minute to delve into this. So there can be 4 kinds of cloud deployment models. While we commonly tend to believe that cloud exists in the cloud, but an enterprise can have its own cloud. So for example, a large bank could create its own data center, launch all its applications, have all the 5 characteristics of being scalable, of being available, of being anywhere access. So for example, today we are doing net banking across the country or across the nations, and the bank that is providing you this net banking service may be doing this within its own premises. So the banks can afford to have high quality IT professionals they can have disaster recovery built in, they can have always availability, large scalability, huge bandwidth, and continuity models, and be able to deploy this. So it's an enterprise-owned private cloud. We could also have a shared infrastructure for specific community. A case in point would be an organization creates a cloud for all its vendors. So let's say Maruti creates an infrastructure and all its vendors log in to handle that. So their supplies and deliveries and their invoicing and their payments can happen through this cloud. And those 5 constituents that we mentioned at the 4-5 slides ago, they are being met. So a community cloud has been created and people are able to use it. Public cloud is something that large data centers and that what we are familiar with are happening. So public cloud examples are many, so many of them. Today you have Amazon, which is a public cloud. So you could log into Amazon, create an account, provision your servers, start running your mail service, go and engage clients, and they could be starting to use your mail service, which is running out of Amazon's web cloud, which you are paying for as a service. So what is happening is that as a service provider, you are delivering email services to multiple organizations from an infrastructure and from a platform which you do not own, but you have subscribed to. I will refrain from using the word leased or rental, but you have subscribed to. So this is a classic example of a public cloud. And wherever these 3 clouds interact or meet with each other, it is a hybrid cloud. For example, a small organization could be running its private cloud and building its disaster recovery center on a public cloud. So you are running an enterprise which manufactures tea cups and saucers. You have your HR application, you have your ERP, you have your delivery supplies purchase portal, which you have hosted within the data center that you own. So it's a private cloud that you have. However, to develop business continuity, you have gone and subscribed to similar set of servers on an Amazon cloud, and all your applications are replicating data there on a 24/7 basis or on once in 24-hour basis. So in case your infrastructure were to go down, you could be able to access this from a public cloud. So you have a hybrid cloud running there. So these are the 4 deployment models of the cloud that exist today. Moving further, what is it that cloud is leveraging? So a cloud is leveraging massive scale. Now what is it trying to optimize is something that we will see as we move forward. It is leveraging homogeneity in delivery of service, heterogeneity in terms of platforms, but homogeneity in delivering of services. It is hugely leveraging virtualization to be able to deliver resource on demand. That is what it is doing. It is also helping people have compute failure proof. So resilience in terms of the servers or in terms of firewalls or in terms of load balancers that come to a cloud computing user. The term low-cost software can be debated, but yes, if somebody were to deliver certain platform software as a service, the software cost will definitely be going down. So if Salesforce.com can deploy a multi-tenanted application which is being used by multiple organizations, what are they delivering? They are delivering low-cost software solution. Of course, they are delivering a product. Of course, they are delivering training. Of course, they are delivering simplicity to use. But at the end of the day, the software cost is being amortized over a large number of users. Cloud leverages geographic distribution. So while till yesterday, when internet was not there, having multiple servers at multiple locations and then combining their data used to be the order of the day, today having multiple server farms and replicating data across these farms for business continuity has become the order of the day. A cloud company delivers what they have is a service orientation. So while having been in the service industry for a long time, it has been a common practice when a software developer comes back and says everything is running at fine at my end. Now that is an attitude which needs to be corrected. If the software is running well on my server, but it is not helping the bank user perform a net banking transaction, it is worthless. But try convincing a software developer about that. He says, no, my environment is perfect and the software is running perfectly here. Every time I make a transaction, my bank account gets debited. But my dear friend, at the customer end, when he is accessing it over the net from his mobile phone, it is not happening. Now the service orientation of the support personnel in the data center is what the cloud computing provider is leveraging. It is not just about saying, thank you sir, we'll get back to you or we'll look into this. It is about being able to solve the problems immediately, which are network related, which are transaction oriented, which are slowness oriented, or it could be a simple network access oriented. Of course, security technologies that a cloud computing provider develops are far, far superior than one can have in-house at a cost. So my statement here is loaded. While you may be able to afford the best-in-class security for your data, but it comes at a cost. But when the same device is serving millions or hundreds of customers, the cost goes proportionately down. At the same time, that money can be used to enhance the security coverage. And it is very simple. We all love to keep our money in the banks and not carry it around all the time, because banks have a better security mechanism than we can ever have. Threat to data is always in-house. Always could be an incorrect word, but is largely in-house. All the murders or the robberies that are happening of senior citizens are performed by people who know these people have got money. Similarly, when somebody needs to pick up your data, he needs to get into your data center, not into the public cloud. It is always more difficult. Now let us look at what are the critical components of a service delivery on cloud. So critical components of service delivery on cloud are, firstly, a 24/7 management of infrastructure. A 24/7 management of infrastructure does not just mean eyeballs. So there are advanced software available which are monitoring each and everything in your server, including the temperature of the CPU. They are going to be monitoring the throughput of a storage device. They are going to be monitoring the throughput of a network device. So what is somebody trying to do? Look at it from the user's point, that a user logs in, there is no bottleneck when he is accessing the portal. Moment he submits his username and password, it is verified against a database which goes through a series of network devices, which goes through a series of storage devices which are being accessed by many people. So this needs to be monitored on a 24/7 basis. It is very simple. If we have a building in which one of the taps is leaking, the pressure in other taps also goes low. Now look at it in a networked environment. Each of the fiber is capable of taking millions of transactions. However, if some of the transactions are repetitive in nature or they are causing a looping in the network, the rest of the transactions become slow. Now this is not as apparent as a leaking tap. So one needs to have monitoring devices or monitoring software in place which inform. Now monitoring software have a tendency to throw back a lot of alerts. Somebody in the data center looks at these alerts, decides which are of important nature, need to be tackled immediately. 99% of them need to be ignored. But the 1% that needs to be looked at are looked at on a 24/7 basis. This is what somebody who is monitoring the infrastructure, managing the infrastructure delivers. Looking at backup and retention, backup is such a critical issue in life. However, retention of backup is equally important. Labeling of tapes, storage of those tapes in fireproof vaults, all this is some that a service delivery cloud has to offer. So you have contractors, cloud provider for backup on tapes on a daily basis. where are these tapes being stored, how are they being retention, how are these tapes being reutilized, how are they being available for use when required. So this is something that a service provider delivers on a continuous basis. Bandwidth on demand needs no explanation. Bandwidth is something that is always in short supply. It is not in short supply, but it is always under constraint. So bandwidth on demand needs to be available. However, we must all realize that the pipes that are delivering bandwidth to a data center have limits. These limits are defined by the telcos who provide these, and these limits must be crossable when the data center demands them. So it is their arrangement with these telcos that is important. Managed security, I'll not talk about this, it is understood. But DR planning, business continuity, and restore services. So while backups happen, restores don't. So backups should be stored properly, they should be labeled properly, and they should be tested once in a while for the restore to be happening. Similarly, a disaster recovery plan requires this thing to happen on a periodic basis. A data center or a cloud service provider delivers all this. Of course, 24/7 support is an order of the day. To be able to talk to somebody physically present who just does not say, I have got your call and will get back to you, but has a correct answer for somebody who's whether asking for DB SQL support or for Windows support or some Linux servers needs to be restarted and then some service needs to be restarted. This is something that are critical components of service delivery. Zero capex is the desirable but not necessarily available option today. So I will draw the stack once here again. Again, like I said at the time of defining IaaS, PaaS and SaaS that there are no defining lines between them and they get blurred. But we'll try and see what are the various services that add to the chain as you move up from IaaS to SaaS. So when somebody is using a simplest form of infrastructure as a service where he is taking his computer hardware into a data center, what does he expect? He expects power and cooling 24/7. He expects monitoring and management 24/7. He expects security 24/7. And he assumes that he will be able to manage his infrastructure himself. So although that assumption may be incorrect, but it may be correct as well. So an IaaS customer is actually looking at security, power and cooling and management and monitoring. While somebody who's delivering a platform as a service, he's looking at additionally manage backups and retention. He's also looking at how, if a disaster were to strike. So if I am a development organization and I have contracted my virtual safe server to a data center, and if the data center were to go through a disaster, how will my source code be protected? It's of concern to me. So a cloud service provider also will be able to give you some disaster recovery, will be able to provide you backup and will be able to provide you with retention, including power, cooling, monitoring, management, DPS, IPS, managed security. So if I were to look at the bottom three stacks of the past, I could replace them with infrastructure as a service. Similarly, if I were to be using software as a service, I would be looking at business continuity in addition to what I have said earlier. Now, all this is based on scalable internet bandwidth and 24/7 support. So if I were to scroll back and look at the slide once again that we saw last, all the constituents that we mentioned there are being covered here. However, I will just go over infrastructure as a service. It does not mean somebody who is using infrastructure as a service will not demand business continuity. He is very well within his rights to be demanding business continuity. He is very well within his rights to be demanding disaster recovery if he has contracted for it. So you could co-locate a server with a cloud service provider. You could ask him to provide it 24/7 power and cooling. You could also ask him to provide monitoring and management, OS patching. Security would be his responsible. You could also tell him that, my SQL needs to be backed up on one of your virtual servers. This backup needs to be stored in a tape and these tapes need to be offsite to be managed by you. In case of a disaster, you should be able to give these tapes back to me, which we take to another data center and rebuild my application. or this process could be automated. So what would happen is the top 3 elements of the stack in SaaS also move to IaaS. So an IaaS customer could be getting all of these. So like I said, this line between them does not exist. However, for the simplicity of explaining, one can see that if you are using IaaS, you have certain stack of services. When you are using PaaS, this stack becomes common. Similarly, when you are using software as a service, then the stack of commonality grows. So these are the service deliverables in a cloud computing, and this is the methodology that one follows in this. So what is it that we are doing? We are doing consolidation, we are doing virtualization, we consolidate servers, storage, power, cooling, connectivity, security. We virtualize all this to give you flexibility, to give you resilience, to give you on-demand computing, and then policies and tasks are automated. This is what the service delivery methodology in a data center or a cloud service provider delivers. Going further, let me just have a very small case study which will talk about, what happens in a typical mail architecture for a small to or medium enterprise serving approximately 500 mailboxes. So you typically have 2 mail servers. One is secondary to the primary. You have a firewall with antivirus and anti-spam, and you have a common database. Now, if this is what you are looking at, what is it that a cloud service provider gives you? So the cloud service provider will provide you lot of services around this that we talked about. The cloud service provider gives you the server availability, it gives you the storage, it gives you the network storage, it gives you network devices, it gives you storage devices, it gives you monitoring of this, and it gives you complete 500 mailboxes running all the time. Excuse me, just a sec, I have missed something here. I just run to the last slide. So if we were to compare, what does a captive data center versus the cloud data center gives? So now in a captive data center, you would typically have a single ISP. A redundant ISP will not be very cost effective. So if you have 500 users, you have 2 Mbps dedicated line coming in, you would hammer your ISP to give you better uptime. However, a cloud provider would have multiple internet bandwidths. It would also have multiple IP addressing. When you have multiple internet providers and you are on your own, the IP addressing becomes a challenge, which a cloud service provider manages. You can have maximum 2 modes of power, utility power plus UPS. However, a cloud provider will have more than that. Your utility power could fail and your UPS could fail to take over. In that case, your servers would shut down abnormally, your data being lost. And it happens. However, a cloud service provider would have utility power, it will have UPS, it will have, those UPS will be in redundant mode, those UPSs will be backed by genset which are also in redundant. Power charges are different. Anyway, power is a premium product in our country, and at times generating your own power becomes cheaper than the utility power that is available. Space has become another premium in our country, which a data center provider optimizes better. Precision cooling is known to extend the life of the servers and better performance. Monitoring 24/7 by 365 in-house is difficult because of the amount of alerts and emails that get generated. While experts in a data center look at emails that are relevant. Security is better. The support services on managed services is better. So team of experts on Windows, Linux, Solaris, multiple platforms is available. So if you were to compare a captive data center versus cloud, these various factors that service deliverables define are better on a cloud. So what does a cloud service provider deliver? It delivers peace of mind. I also have an Excel sheet here, which I can throw up, which shows various constituents of a cloud versus in-house cloud infrastructure. So there are capex heads which talk of, you could take Windows Server. What I have done is here put $1 as a price, because prices could vary and we could get into a discussion as to what is the price. And I have tried to list here what are the various constituents of capex heads, which includes servers, which includes their AMC, and then amortizing their cost over 3-year lifespan, which includes SQL Server, which includes Windows Server licensing, which includes CALs, number of people using it. Then there are firewall and AV and AS support, amortizing these costs over a few years, support charges on storage and allied switching equipment, and then again amortizing it. So all these, when totaled up over a 3-year period, you can derive certain costs. These figures here are not available. I can share this template with anybody who desires, and you could fill up the numbers here and get your figures done, calculated. Similarly, going down, what is important is that going down, I have complete power consumption calculation based on rated power supply of each of the server, based on each of the server node consumption, cooling load, then charges for in-house gensets, then charges for cleaning power, and then we come up to a total electricity charge per server. We then proceed down with manpower resource calculation. That what are we need manpower for server upkeep, we need manpower for support, we need manpower retention and training, there is management overhead. So I have created a template for all of these costs. And that is how we derive our total average expense in maintaining running your own servers. We divide this by number of users and come to a per unit cost. However, in our owned environment, this does not include equipment depreciation, it does not include interest on capital, it does not include breakdown cost, it does not include real estate, it does not include 24/7 support. And there is no committed uptime. So while the cloud computing cost would be very simple, you get a total cost per user per mailbox, multiply that with number of users, and you get a cost. Just subtract the total, and you know what is the cost benefit analysis. However, you will get redundant equipment, you get scalable solution, you get unlimited bandwidth, you get server management, and you get 99% uptime. This is what a cloud delivers, and these are the various constituents of service deliverable in this. I think that is all I have for now. Thank you very much for being a patient audience. I will be happy to take questions now. Thank you.
Thanks for the insightful presentation, Mr. Vipin. Let's quickly take up the questions now. Please read out the questions and their answers so that all our users may listen to the commendable insights.
Surely.
Sir, I've already assigned you a few questions. If you can see in the questions tab.
Where do I see this? I can't see any.
Can you see it now?
No.
Okay, just click on the view tab above and just see if the questions tab is checked or unchecked.
View question, it is checked.
Okay, you would be seeing a questions tab that would be below.
I'm not getting any questions here.
Okay.
Can you read that out to me? I can see questions.
Yeah. I
can see it now.
Okay.
So, going to the first one, does the cloud provider regularly test disaster recovery plans for data processing facilities? The answer is both yes and no. No, DK, as I see your name, this is a part of the SLA that you drive with your service provider. A testing of disaster recovery plan is as important as drawing a disaster recovery plan, and this includes two ways. For example, you have declared a disaster and your site, you have restored your data onto another site. Now when the disaster is over, how does the data, incremental data, get back into your main data? This is what you have to conclude, and this is what you have to discuss with your service provider. So all of them do not provide this facility. You have to, as a customer, you have to ask for it. Does that answer your question? Next question is, elaborate the difference between private and community cloud. A private cloud is a closed affair. Let's say you have an organization which is just running email. So you have 500 employees, you have set up your own cloud, and all those 500 employees are using this as an email service. However, when you open this email service to your vendors who are part of your community, but let us say you create their mailboxes also on your cloud. So all your vendors are listed, which are grouped separately. This is a simple example where you have a private cloud or you have a community cloud. So Maruti has a cloud. Maruti's employees are running on that. They create also their vendors accounts and their stuff runs from there. That's a simple case of a community cloud. Apart from Salesforce, there are so many other SaaS available in the cloud. Facebook is a SaaS, LinkedIn is a SaaS. These are all applications. If you look around you, you will be flooded with so many other applications. Orkut is an application which is a SaaS deployment. Going further, can you please put up the hosted mail case study slide again? Yeah, it is on the screen. Can you just have a look at it again? Or do you want me to put up the Excel sheet? About this unlimited bandwidth, we could take this separately because this is a calculation that I can explain to you. But if you could write to me, or I don't know how TechGift would enable this, but we could take this definitely offline and I could explain this to you, which could be published also. I have got some calculations based on this, which will take some time to explain. Is cloud computing compatible with all OS? You see, OS is, when you talk of cloud computing and virtualization, so virtualization layer is what presents the hardware to the OS. For example, if you are from the old school, when we were studying computers, we were very clearly informed that one hardware runs one OS. This is not true anymore, but this is still true. So let's say when you have a layer of virtualization, it prevents an individual hardware to each OS. So one physical layer of hardware runs multiple OSs, but those OSs still see one single hardware. So when you ask me, does cloud computing compatible with all OS, the answer is yes, but not a categorical yes, because I don't know if some OS may be incompatible with this. But yes, you could be running Windows, you could be running Windows XP, you could be running Windows 7, you could be running Windows Server 2K10, you could be running Windows Server 2K8, you could be running Linux, you could be running Ubuntu, you could be running Red Hat on the same physical set of hardware. One box could be doing all of these. Yes, it is possible to use one cloud vendor for primary and another for DCP-DR, 100% possible, and it is an implementation that is popular in the world. When is it the time to understand whether it is to move to cloud or leaving your own servers behind? When you realize that your cost of hosting it in-house is getting more than your cost of hosting it outside. Economic driver is the biggest driver. You could also be located in a remote location where your support personnel are not available. So it is more wise to be running on the cloud. So geographical location could also decide this. I thank you for saying that the presentation was good, Ilya. Well, the amount of confidence that you have in a bank when you put your money there, or when you take a locker from a bank and put your valuables which are unaccounted there. By unaccounted, I mean there is no list that the bank maintains, but you safely put lakhs of worth of your jewelry into a safe with the confidence that it is available to you whenever you want within the banking hours. Same is the data safety that a cloud provider can provide you. But you have to choose your cloud provider carefully and understand what kind of safety devices has he put in. You should be able to consult somebody who can give you an expert advice on this. Cloud vendors amortize the cost of server over large number of users. That is why they can offer this low. If you want, I can mail this Excel sheet to you and you put your figures in this. Then you will realize that the cloud becomes cheaper because the cost is amortized. Does the cloud provider follow certain confidential data destruction policies? Yes. There are standards for this. People who are following ISO 27001 will understand this, and there are measures to ensure this. Can I create my private cloud at my home with my desktop as a SaaS for my laptops? Yes, you can. You should be able to put a layer of virtualization on this and then provide it with an IP address that your laptops can access it. It is possible. A simple equipment which is desktop is powerful enough to run a virtualization and host of applications on it. It is possible, yes. Does the cloud provider have a formal change control process? Most of them, yes. You can ask for it. It should be a document that they can present to you. I think that was the last question. Is there any other that I need to address? Except for one about the cost that I need to explain in detail. I think there are no more questions. Can a cloud provider provide results of a third-party external audit? I really don't know the answer to that. I have not come across this in my career till date. I really don't know the answer to that, if we can provide the external audit results or not. How to monitor hosted servers? There are many tools available for that. You could look at SolarWinds. You can look at Nagios. So many tools available. Any other questions? Are there any measures to protect IP rights of an uploaded app? Yes. The answer to that is yes. How do you want me to explain this? Just write it down. I'll be happy to address this.
So there are a few more questions I've just assigned. if you can see. Vipin sir? Hello?
Hello?
Yeah, Vipin sir,
Yeah.
there are a few more questions I've just assigned, if you can see.
I can only see the last one. Just a sec. Ajay is asking, hello sir, please tell me in which company having good infrastructure for cloud? I don't think I can answer that question. There are a lot of companies offering a lot of infrastructure. I don't know what will you mean by a good cloud. Are you talking about security? Are you talking about scalability? Are you talking about bandwidth? So, your definition of good has to be clear. How to assure customers that their IP is protected? You see, your data center provider can offer a lot of security around the usability of application, but it will not be able to provide you any IP protection. A cloud service provider does not have any IP protection. It does not have the teeth for that. So what does a cloud service provider give you? It gives you an infrastructure, it gives you a platform, and it gives you accessibility, it gives you solidity, it gives you monitoring. You can ask for if my application is being copied. So you can restrict access to that. So you can have some restricted access to certain rights, but he will not be able to protect your IP. That is somebody else's job. What are the challenges may come when we use cloud? One of the challenges that when you use cloud is that you have to offer cloud to be accessed by multiple devices. For example, Hotmail is a cloud application which is running on laptops on Windows 8. Now it has to run on Windows XP, it has to run on Windows 3.1, it has to run on Ubuntu, it has to run on Android, it has to run on iOS. So these are so your application must be tested thoroughly on multiple platforms before it can be hosted on cloud. Do they provide access to auditor to look into the security controls that cloud vendor has implemented? Yes, this is possible. You can have external agency conduct a penetration test onto your application, conduct a security audit, which a cloud service provider will give you access to. They will normally have a written policy towards this, which you can ask for. Have I answered all the questions, Shweta?
Yeah, Mr. Vipin.
Any other queries?
No, there are not any queries, I guess. Yes.
So I still say there are about 68 attendees left, and I would like this opportunity to thank all of them. I would also like to express my gratitude towards Salesforce.com, whose application I have given reference to Amazon.com for quoting their CEO, to a lot of times I've used Windows and Exchange as terminologies, and I would like to express my thanks to those. Thank you, everybody. Thanks, TechGeek, for giving me this opportunity to present.
I'm really thankful to Mr. Vipin for conducting this webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgeek.com by tomorrow. Thank you all.
Thank you.